We want to determine the domain and range of the function f of x equals the absolute value of x plus 2 minus 3. The domain consists of all possible inputs or x values for the function, and the range consists of all possible outputs or y values for the function. Now there are a couple of ways of determining the domain and range. We could use what we know about the properties of the absolute value function to determine the domain and range, or we could also make a graph of the function and analyze the graph. Let's start by analyzing the graph. So the first step would be to either make a t-table or use technology to create the graph provided here. Once we have the graph, we can analyze the behavior of the function horizontally and vertically to help determine the domain and the range. What I mean by that is, to determine the domain, if we were to project this function onto the x-axis, notice how it would include the entire x-axis. Another way to think of this is the graph continues to the right and continues to the left indefinitely without any holes or breaks. So the domain approaches positive infinity to the right and negative infinity to the left. Therefore, the domain of this function would be all real numbers. Or if we wanted to use interval notation, we could use the interval from negative infinity to positive infinity. Now to determine the range, we would have to project the graph onto the y-axis or determine how the graph behaves vertically. Notice how the lowest point on the graph is this point here with a y value of -3. And then from here, of course, the graph is moving to the right and left very quickly, but notice how it's also moving upward. So if we projected this graph onto the y-axis, it would actually approach positive infinity along the y-axis, which means the range would be from -3 to positive infinity, and it does include -3, so we can say the range is greater than or equal to -3, or using interval notation, it would be the interval from -3 to infinity, and it's closed on -3 because it does include -3. Now if we didn't want to make a graph, and we knew a lot about the properties of the absolute value function, we could use reasoning to determine the domain and range. What I mean by that is we could think to ourselves, what are the possible values of x that we could use to substitute in here and then evaluate the function? And the answer is we could use any real number here, add 2 to it, take the absolute value, and then subtract 3. And that's the reason why our domain is all real numbers. And then for the range, if we knew the absolute value of a number is always going to be greater than or equal to 0, well, if this is always greater than or equal to 0 and then we subtract 3, then the function value or y value is always going to be greater than or equal to -3. Again, if this value right here is always going to be 0 or some positive number, then the function value or y value must always be greater than or equal to -3, which is our range. So I know it can be challenging to just think about what the domain and range would be given the function. So I think it's always helpful to sketch a graph of the function and analyze the graph, if nothing else, just to verify the domain and range.